I'm Vashon Tanwebing. Welcome to our video presentation titled Smart Bus Tracking System. A smart bus tracking system is a way to track bus status using modern technologies. These technologies include positioning, sensing, cloud, and software application. With a smart bus tracking system, passenger can see the bus location and seat availability in real time, allowing them to make decisions around it. In the past, there's no bus tracking. Buses are expected to arrive at the bus station at a fixed time interval. Then comes station arrival tracking, where bus arrival information are displayed only at the bus station. Today, we can have smart bus tracking, where information can be retrieved anywhere, anytime, on any smart devices. Both the locations and seat availability are tracked in real time. In the future, we may not have physical bus stations. Virtual bus stations can be allocated and scaled based on passenger demand. Bus may also implement adaptive routing, where bus routes are determined by the passenger demand as well. More bus will go to the bus station with more people and vice versa. With that said, bus transport has fallen out of popularity in recent years. And one of the reasons for it is bus station waiting times remain unchanged. This is due to the lack of current location indicator, which is what our smart bus tracking system aims to tackle. With two main objectives, the smart bus tracking system aims to reduce bus station wait time. We do this by providing real-time location and seat availability of the bus. This is the smart bus tracking system architecture diagram. It starts off with IoT devices sending location and human count data to the cloud through IoT call, where AWS Lambda will store this information in a DynamoDB database and send notification of any arriving bus. The passenger, on the other hand, can retrieve this data through Amazon API Gateway, where AWS Lambda will return the data stored in the DynamoDB database. Alongside with Amazon Location Service, the passenger can view this data on a visual map, providing a more clearer picture of the information at hand. Finally, we study the different IoT platforms available. We begin with Amazon Web Services. AWS split their IoT platform into three main categories. 1. Device software, which consists of free RTOS and OS for microcontroller, AWS IoT Greengrass, and Edge Device Runtime, and AWS IoT ExpressLink, a platform to connect hardware modules developed by AWS partner. 2. Connectivity and control services, which consists of AWS IoT Core to connect IoT devices, AWS IoT Defender, a security service, AWS IoT Device Management for easy management of large-scale IoT devices, and finally AWS IoT Fleetwise for collection and management of vehicle data. And 3. Analytic services, which consists of AWS IoT Sitewise to collect and analyze industrial equipment data, AWS IoT Events to respond to certain IoT events, AWS IoT Analytics for analytics, and finally AWS IoT TwinMaker to create a digital copy of real-world IoT system for a better view. Next, we study Microsoft Azure. which split their IoT platform into two main categories. 1. Connectivity and Analytics, which consists of three sub-products. Azure IoT Hub to connect IoT devices, Azure IoT Central to handle large-scale IoT devices, and Azure Digital Twins to create a digital representation of the real-world IoT system for better insight. And 2. Edge and Device Support, which consists of 5 sub-products, which are Azure IoT Edge, a runtime for edge devices, Azure Percept, a platform to integrate specialized hardware accelerator into the cloud, Azure Sphere, to connect microcontroller developed by Microsoft Silicon partner into the cloud, Windows for IoT, a Windows operating system license for IoT devices, and finally Azure RTOS, to provide a powerful operating system to resource-limited IoT devices. The third IoT platform provider that we study is Google Cloud, which has two IoT products. 1. IoT Core, to connect and manage IoT devices, and 2. Edge TPU, is Google's purpose-built chip to run machine learning computation on edge devices. Comparing the IoT platform providers yield interesting results. 1. All three IoT platform providers provide basic connection, management, and data redirection of IoT devices. However, Google Cloud lacks many IoT products when compared to the competitors. And third, AWS does provide more IoT products than Microsoft Azure.
My name is Wong Kei, and now I'll talk about the AWS Lambda and the API gateway. So first we'll talk about the Lambda part first. So in the console, we type the Lambda, and in the services, we enter the Lambda services. So here we want to build the function. So we already have the two functions, which is the updater function and location function. In order to build a function, we need to click this create function button, and we need to choose this author from scratch, and the function name we just simply type maybe test function, and then the runtime we need to choose this Python 3.99 because we are using this version of Python, and architecture we choose this one, and for the default execution role we use the existing role because we already have existing role, and then we choose this one, which is the service role location role, and then we click this create function. And now we already successfully created the function, and after we create the function, in the code source part we need to enter the code, and here we already typed the code, which is this one for the updater. And then I will talk about how to connect the updater function with the AWS IoT, because we can look from the architecture diagram. Our AWS Lambda is connect with the IoT core. So how to connect it? We search for the IoT, and then we enter the IoT core. And then we choose this add, and under the add we choose the rules. Here we already have one rule, which is the invoke lambda rule. So how to create the rules? We click the create button, and then we can enter the name of the rules and the description. And for the SQL version, we're using this SQL version. And then we need to add the action. So our action we choose this one, which is the send a message to a lambda function, because we connect it with the lambda. Then we'll click this configure action, and then we need to select the function, which is the updater. Then we click add action, and after we do it, we will need to click this create rules. So after we click the create rules, we need to here add trigger, then we connect it the AWS IoT. So this is same with the AWS Lambda in here, which is the location Lambda, and we also need to connect it with the API gateway. So for this Lambda, we need to connect for the API gateway, which is also same with the updater function. So then I will talk about the API gateway part. Then we need to type the API and we enter the API gateway. So we already have one API which is named bus. So we need to create the API. We click this create API, and then we select this REST API. We click the build, and after we enter this, we need to select this REST, and this is the new API. Then we enter the API name and the description. Then we click this create API. So we have something here, and we create this API. So after we create this, we will enter this page, and then we need to click this action and select the create method. Here we will have some selection for us to select. Then we click this get, and we click this enter. And after we enter this page, we need to type the Lambda function. We type the location, then we click the save, then we click this OK, and we successfully create this get. And then we need to create the next method, which is the option, and then the any. So which is same with this. So which is same as this. Yeah, we need to create like this. So that's all from my part. Thank you.
To confirm subscription for this email. So, okay, we go to. Okay, here is this is the AWS confirmation subscription confirmation email that we received after we create the subscription. Okay, we click on the confirm subscription. A page will show up, and then it will say subscription confirm. Okay, now we go back to the console, and then we refresh it, and see the status of the subscription will becomes confirmed. To test if the email can receive if the email can receive the notification, we go to the topic, and then we select the topic we created, and then we press on public message. Okay, then go to the message board. For the subject is optional. If you want to put a name, let's say put is coming. Okay, then go to the message body. We will insert a message such as +1 is coming. Okay, then Okay, then we go to the water and then publish message. Okay, now we go to the email.
Hi there, my name is Win Yuen, and now I'm going to continue this demo sessions. For my part, I will be mainly demo the map. So first we will go to the Amazon console and type in locations. To open up the Amazon location service. In this service, we'll go to the left side, expand the menu, and go to the maps. After that, we can create a map. In our case, we already created a map called bus tracking maps that is being provided by here. So this is the map name, bus tracking map. After we have created the map, next we will going to embed these maps with an Amazon Cognito identity, which is for the authentication purpose. So we will go to the console and type in Cognito. After we enter Cognito, we'll go to Manage Identity Pool and create a new identity pool. For our case, we already created a pool called Location Pool. This location pool that's been created will be mainly for unauthenticated users, so they can use our application without logging in. For this pool, it will come with an identity pool ID that will be used in the later coding part. Now we'll go to the coding part. So this is our web applications from top to the bottom. So at first, we will need to integrate this map by calling the amplify Joe JavaScript library. So this is all the calling the libraries. After that, we'll go to the style and set the body and map so that it will display our map in a full screen. Then we'll go to the amplify configuration. We'll configure the identity pool ID, which is the pool ID that I mentioned earlier. So we'll give access to the users so that they can use the map without logging in, and also set the region. Then we will go to the geo under Amazon location service under maps and items. We will give the map name, which is the bus tracking map that we created earlier. So they can use this map, and also we specify the region. Then the following function is the initialize map. For this, it will create a maps and set the center locations, coordinations, and also the zoom rate. So it will display the way we want. Then we will continue with the following coding part. The following coding will mainly around the markers. We'll create 3 markers to display the bus stop 1, bus stop 2, bus stop 3. And also we will create 3 markers in different color to represent the 3 buses. Then we will go to the functions called load document, and we will fetch this URL. This is an API that we can get from Amazon. We go to Amazon console and type API gateway. In this Amazon API's gateway, we already created a bus API. In this bus API, we go to the stages, then we go to the left, and here comes the URL. So in our application, we'll invoke this URL using the method get. Then mainly the functions of the load document is to set the buses with their passenger amount and also set the location, longitude and latitude. So now I'm going to display the map. So when we run the map, it will be displayed like this. It will show the maps with the location that we want. Then it will coming with 3 black dots, which is the bus stops, and also the 3 markers, which is the bus. So when we click on the bus, we'll know which is the bus and the amount of the passengers. So that's all for our presentation. Thank you.